Good afternoon. In this video, we are going to talk about proposition 6 from book 1. Okay. So before we start the video, I would like to say that Euclid had used a method called proof of contradiction in this proposition, and we'll talk about it later. Okay. So proposition 6 states that given a triangle and two angles are equal to each other, then the subtend sides are also equal. Which means, for example, in this triangle ABC, we are given that angle ABC is equal to angle ACB. They are equal. Then we can conclude that the subtend sides are equal, which means AB is equal to AC. Okay, so now let's prove it. First of all, let's make a hypothesis. In this hypothesis, we assume that proposition 6 is false, which means given ABC, angle ABC equals to angle ACB, we have that AB is not equal to AC, okay? And for convenience, let's just assume AB is greater than AC. Okay, so please recall proposition 3, given two unequal straight lines, we are able to cut off the longer one to get a part which is equal to the shorter one. Okay, so let's skip the steps and assume we have cut off AB because AB is the longer one to get a straight line BD which is equal to the shorter one AC. Okay, so we have BD equals to AC. Great. And now please recall postulate 1. Given 2 points, we can join a straight line. So let us join C and D together. Joining them together, then we have straight line CD. And please note that we are given the condition that these two angles are equal. Okay, so let's combine them together. ABC is equal to ACB, and we have BD is equal to AC. And meanwhile, the BC, this side, is shared by this triangle BCD and this triangle ABC. So what do we have? BC is equal to BC. Please recall proposition 4. We have side, angle, side equal relationship. So we can conclude that triangle ABC is equal to triangle ABCD CB. Sorry, triangle. Okay, so which is contradictory to common notion 5. Recall common notion 5, the whole is always greater than the part, so A is greater than B. So in our proposition, this triangle ABC, it is whole, while DCB is a part. So we should have ABC is greater than DCB, but we have concluded that they are equal, which is incorrect. So that means our hypothesis is incorrect. So our original proposition is true. So this proves the proposition. Okay, so let's talk a little about the proof of contradiction. In this kind of proof, we are using this method. So basically, we have a proposition to be proved, like P, and in this proposition, P is this. Okay, so at first we hypothesize that P is not true. Okay, this is a hypothesis, right? P is not true. And based on this, we are able to derive some kinds of conclusion like Q, which is contradictory to something we know, for example, a condition we know or a known truth. And in this example, Q is the relationship of these two triangles, which is contradictory to common notion. It is known truth, so they are contradictory. And then let's say it is contradictory to something, some truth, and then this can derive that our original proposition P, it is true. Okay, so that's a brief introduction. If you are interested in these proof methods, just refer to the topic of proof of construction or proof of contradiction or contradiction method. Okay, and in the next video we are going to talk about proposition 7. Thanks for watching. Have a good day.